Hello, this video is for IXL, activity 8.N.2. It is titled Quadrants and Axes. The 3-character code for this activity is K77. So, talking about the coordinate plane, it has two axes. It has a y-axis going vertically and an x-axis going horizontally. And this is going to separate the coordinate plane into 4 separate quadrants. The first quadrant is up here in the upper right. This is quadrant 1, and many people might think that we actually count them going clockwise. They're actually done going counterclockwise in this direction here. So quadrant 1 is the upper right. The upper left is quadrant 2. The lower left is quadrant 3, and the lower right is quadrant 4. So those are the 4 quadrants of the coordinate plane. So let's go ahead and with that information, let's go ahead and see if we can find the answer to our questions. And which quadrant is point R? Well, we see point R here, and so we can see that this quadrant is bound by this portion of the x-axis and this portion of, the y-axis and this portion of the x-axis. So it is indeed in quadrant 2. On the next one, we're looking for which point is in quadrant 3. Well, we know that this is quadrant 1 here, and quadrant 2, quadrant 3, and quadrant 4. Now, interestingly enough, if I were to do this to be more accurate, I should do this as quadrant 1 using Roman numerals. This is quadrant 2, and here is quadrant 3. And here is quadrant 4. So whether you want to use Roman numerals, regular numerals, either way, but it's one place in mathematics that we still use Roman numerals. So quadrant 3, let's go ahead and identify quadrant 3. That's going to be bound by this portion of the x-axis and this portion of the y-axis. So over here is quadrant 3. So we see that point R is in quadrant 3. So the answer is R. Which point is in quadrant 4? So again, quadrant 4 is in the lower right side here, bound by this portion of the x-axis, or I keep getting those backwards today, don't I? This is the x-axis going across, the y-axis up and down. All right, so which one is in quadrant 4? Well, we can see right here is point Q, so we will select point Q. Now, we're going to go ahead and talk about something else here about the quadrants that's unique about them. Is that if you notice that everything over in quadrant 1, and I guess I'll go ahead and use a Roman numeral. Everything in quadrant 1, notice that all the x values, and I actually want a line, I don't want to do that. Notice that all the x values are positive. So anytime we have an ordered pair here, remember an ordered pair, a little bit of conversation there. Ordered pair, P-A-I-R. An ordered pair is an x value and a y value separated by a comma contained inside of parentheses, in which the x value is the input and the y value is the output. So all the x values here in quadrant 1, if it starts at 0 and goes to the right, you'll see that all of those are positive. And likewise, if you look at all the y values, they start at 0 and go to all the positive values for y. So in this case, the y values are positive in quadrant 1 as well. So x values and y values in quadrant 1, both positive. Let's look at quadrant 2, Roman numeral 2. Now, over here in 2, if we look at that, notice that all the x values going this way, anything in quadrant 2 would have an x value that is negative. So the x values are all negative. However, here, when we look at that, and I guess I'll use a blue line again, as we go up through here, we see that just like in quadrant 1, all the y values have a positive value. So everything in quadrant 2, negative x, positive y. Moving along to quadrant 3, we notice that for all of our x values going to the left here, they would all be negative. And all the y values, and could I possibly change to another color or another line? Maybe so. So for 3, notice that all the x values are negative, and likewise, all the y values are negative as well. So anything in quadrant 3 is going to have a negative x value and negative y value. And then finally, over here for quadrant 4, IV, let's see, I think I could actually come up with one more color there. Notice that all the x values, just like quadrant 1, are positive. So anything in the first quadrant is going to have a positive x value. Now, what about all the y values? If we look at all the y values, these are all going to have negative values for quadrant 4. So anything in quadrant 4, its y value is going to be negative. So now we've kind of set up a shortcut or a helpful piece of information that might be able to help us find our answers. So notice in review, quadrant 1, positive, positive. Also, it's the opposite quadrant over here in 3 that's like catty corner from it where they're both negative. So quadrant 1, both positive. Quadrant 2, both negative. I said quadrant 2, didn't I? Quadrant 3, both negative. Okay, over here at quadrant 2, the x is negative, y is positive. X negative, y positive. And it's just the opposite over in quadrant 4. X is positive, y is negative. So if they want to know which point is in quadrant 1, we could plot each of these. We could go 1, negative 3, and let me go ahead and erase all this here. Right, and we'll erase that portion of it. I could have thought, okay, 1, negative 3, 1, negative 3. I could have said, okay, there's 1 there. Oh, nope, that's in 4. Negative 4, negative 2. Negative 4, negative 2. Plot that. No, that's in quadrant 3. 3, 5. Over here to 3, up to 5. Yep, that's in quadrant 1, so 3, 5. Now, what if 3, 5 had been the last answer? Then you would have done, well, negative 5, positive 1. Right? Nope, that's in quadrant 2, so it has to be this one here. Well, if you knew that everything in quadrant 1 were positive, positive, you could just look down here at the answers and find the one that has both positive x and positive y. And that also would be 3, 5. So let's try that here with this one. Look at the coordinate plane, which is in quadrant 2. So over here at quadrant 2, we know that x is negative, y is positive. So we're looking for negative, positive. Negative, negative, nope. Positive, negative, nope. Negative, positive, oh, sure enough, right here. Negative 3, positive 3. And that's going to land right there, okay? The other one's positive, positive, so that's going to be in quadrant 1. Now, they take away the graph, right? They don't even give you the graph. They just say which point is in quadrant 2. Well, if we think back, quadrant 2, that's negative, positive, right? Over here, quadrant 2, negative and positive. So let's look for negative, positive. Positive, negative, nope. Positive, positive, nope. Negative, positive, yep, that one works. It would be there. And then negative, negative. Which quadrant is the point for negative 4? So we're looking for positive, negative, right? Well, positive, negative is where we have a positive x value that's going this way, and then negative y values. So that's going to be down here, right? So everything down here is a positive, negative. And isn't that what negative 4 is? So it must be quadrant 4. Which point is in quadrant 4? Well, we just realized that quadrant 4 is positive, negative. So let's look for that. No, negative, negative, positive, positive. No, negative, positive, positive, negative. So it's this one here. 2, negative 1. It would be like 2, negative 1. It would be right there. And that is indeed quadrant 4. So it's kind of a trick way of being able to figure that out. Remember, again, it is quadrant 1 where it's positive, positive. And it is quadrant 3 where it is negative, negative. Now they start up with these inequality signs. You like this less than, greater than type stuff. Well, don't let this freak you out, okay? Because if x is less than 0, then that means that x is what? Negative, right? And if y is less than 0, then that means that y is negative. So in this case, we're talking about a situation where we have a negative x and a negative y. What quadrant is it in? Well, these are both negatives, right? So remember, that's over here in quadrant 3, where everything's negative, negative. And what I did a 1 there for, I do not know. There you go. So that would be quadrant 3, because x is less than 0, that means x is negative. Y is less than 0, that means y is negative. Here's another one here. X is greater than 0. Well, anything greater than 0 is positive, right? And x is less than 0. So in this case, y, positive, and y is less than 0, so we're talking about y is negative. So where is x positive and y negative? Isn't that quadrant 4? Everything here is positive. X is always, erase. Oh, that's an undo. I guess we could undo too. So x is always positive here, and y is negative. Isn't that what we have here? Positive x, negative y, quadrant 4. So there we go. And on this one here, x is less than 0, so x is negative. And here, y is greater than 0, so y is positive. So where do we have a situation where x is negative and y is positive? Isn't that up here? X is negative, y is positive. This is quadrant 2, so we're looking for quadrant 2. And final 4 questions. This is all about whenever it's on the axis. Whenever your point is on the axis, how does this work out? So if the point xy is on the y-axis, which of the following must be true? Well, here's the y-axis, right? And here's the x-axis. So let's put a point on the y-axis, anywhere, just there. What would the value of x be? Well, the value of x, right here, would be 0, right? So in this case, it's 0. So if it is on the y-axis, then the value of x has to be 0. Likewise, if the point xy is on the x-axis, which of the following must be true? So let's pick a point. We'll change colors. Let's go with the black dot. Let's just pick a dot, put it on the x-axis. Now, what is the value of y at this point? Well, if y is the up and down, well, it's neither up or it's neither down. So in this case, y has to equal 0 at this point, right? So y is going to be 0. So if it is on the x-axis, then indeed the value of y is 0. So it's like the opposite. It's on the y-axis, x is 0. If it's on the x-axis, y is 0. All right, another way of doing this, looking at this same type question. If x is greater than 0 and y is equal to 0, where is the point located at? Well, if the value of y is 0, no matter what the value of x is, we know that it is on the x-axis, right? Where's the value of y 0? Everywhere along the x-axis. So if the value of y is 0, it's on the x-axis. If the value of x is 0, then it's on the y-axis, right? Anywhere that, where is x 0? All up and down the y-axis. Anywhere here on the y-axis, x is 0. So if x is 0, we know it's on the y-axis. So a little bit of a trick there, right? Kind of keep that in mind. And that completes all of my examples for IXL 8.N.2, quadrants and axes. And good luck with your activity.